All right, happy Thursday to everybody. We are going to be doing another Museums from Your Home live stream this morning. We're going to be talking about trace fossils. So we're going to just take a couple of seconds here to just make sure that we are in fact live. We should be on Facebook at the Alabama Museum of Natural History's Facebook page, as well as the UA Museum's YouTube channel. So it does look like we are live on Facebook, and that's working well. StreamYard hasn't failed us yet, but we like to just check it first. All right, so we are live on Facebook and YouTube. So if you have any preference to which platform you watch it on, you have the availability to watch it on both. All right, so I guess now that we are started and working properly, I guess we'll go ahead and kick off the live stream. Welcome to today's Museums from Your Home live stream presented by the University of Alabama Museums. My name is Rebecca Johnson, and I am the Communication Specialist for UA Museums. And today I am joined by Allie Sorley, the Alabama Museum of Natural History's Education Outreach Coordinator. And Allie, I see that we have some guests with us today. Would you like to introduce them?
Sure, yeah. So today we're going to talk about coal age trace fossils in Alabama. And I think it might be best if everyone introduces themselves so that we can all get to meet everyone. Do we want to go ahead and start with maybe Dr. Klompmaker?
Sure. Hi, my name is Adia Klompmaker. I'm the curator of paleontology at the UA Museums at the University of Alabama.
All right.
I'm David Kopaska-Merkel, and I work at the Geological Survey of Alabama, right across the parking lot from the museum.
I'm Ron Buda, retired professor of astronomy, University of Alabama.
And I'm Andy Rinsberg. I work at the University of West Alabama, teaching geology and paleontology.
Well, that's awesome. Thank you all for joining us today and joining the live stream here. And just as a reminder, we're going to be live here on Facebook and YouTube. So feel free to ask any of these folks any questions, or if you have any comments, make sure to leave them in the comment section so they'll be able to see them. And as a reminder, this is also live, so anything can happen. So hang in there with us in case we have any connectivity issues or anything like that. Hopefully nothing like that will happen, but this is live, so just keep that in mind. All right, well, now that we've gotten all of that out of the way, Allie, how should we get started today?
Yeah, so today we are gonna, like I mentioned before, talk about some trace fossils from the coal age. We are, everyone that's here with us is an incredible expert on the topic. And so we've got some really great slides and pictures and things and information about the topic. But two of the main sources that we're using that might be of interest to people. Let me go ahead and share my screen really quick. If we could get my share screen up, that would be great. All right. So, we have links to these resources available below in the description box today. But we're going to be talking about this Pennsylvania footprints in the Black Warrior Basin of Alabama, as well as footprints in stone, fossil traces in coal age tetrapods, which I've got my copy here. Looks like a couple of us also have our copies, and a couple of us have the copies of the Black Warrior or the Pennsylvania footprints one as well. But these are two of the main sources that we're going to be talking about today, other ones as well, but we thought we would like to share these two at the beginning to kind of let you guys know where we're going from. And then thankfully, or as you guys can see, we've got all of the editors and authors on with us today. So this is kind of great. But I feel like maybe we should, I don't know, Dr. Klompmaker, do you want to get us started?
Yeah, absolutely. Can you hit hide in the screen, by the way?
Oh, yeah, Allie, Adiel was saying, can you hide the screen at the bottom on your share screen? Yeah, there we go.
Yeah.
Got it, sorry.
Thank you, thank you.
Welcome.
So what I'm going to do now is give you a short introduction about trace fossils after we're going to go into our main topic. Next slide, please. So what is a trace fossil? A trace fossil is not a body fossil. So it's not a bone, it's not a tooth, and it's not a shell. No, it's a structure caused by the activity or behavior of an organism modifying a particular substrate. And the substrate may be anything from the bottom of the ocean soil on a continent, or even a shell. Next, please. So trace fossils are also called ichnofossils, and ichno is coming from the Greek ichnos, meaning trace or track. So the study of ichnofossils is called ichnology, which is essentially an important subfield of study within paleontology. Now, trace fossils are formally named, so they get an ichnogenus, an ichnospecies, and sometimes even a family name. The reason why scientists do that is to communicate better with one another which type of trace they are talking about. Now, I should mention too here that the animal that made the trace gets a different name. So the trace animals may get a different name as well, so keep that in mind. Next slide, please. So to give you some examples of trace fossils, here you see an example of a burrow into a bottom of an ocean. There are a number of footprints here. On the left-hand side, we see a horseshoe crab at the very end of its trail, which is extremely rare, but here we can actually see which animal made the footprint specifically. On the right-hand side, we see footprints of a dinosaur. Got the resting places as well, where certain animals were sitting on the bottom for a while, leaving their outline behind. And here's an example of a pillbug-like animal living in the oceans back in the days called a trilobite. Different type of example, but trace fossils are borings, so animals seeking a home within a shell, for example. In this case, you see all kinds of boreholes in this clam shell, most likely made by a sponge, just living within the clam. So then we have a variety of food processing traces. On the left-hand side, you see a clam with a giant hole in there. This is a hole made by a predatory snail drilling into the shell to get to the soft tissue inside. And on the right-hand side, we see a coprolite, or essentially fossil dung, that is left behind by an animal too back in the days. Now, trace fossils are extremely useful, but they can also be very challenging. I'm just going to show you some examples of their uses. The first use is identifying the presence of organisms in the absence of body fossils. Sometimes you don't have a shell, you don't have a bone, you don't have a tooth, so you don't know whether the animal is actually there, but you may have the traces they have left behind. So we can also infer how organisms live by studying trace fossils. Where organisms lived, particularly, we can use all kinds of predation and parasitism traces and identify how food webs back in the days look like, and also how these animals lived within their particular environment. The trace fossils are also used to date rocks or sediments. So now we go to some of the challenges. An organism can produce different traces representing different behaviors of the same particular animal. Think about a squirrel making footsteps and a squirrel gnawing on an acorn. These are two very different traces, yet they're made by the same organism. So the same behavior of an organism may result in different traces in different substrates. So for example, think about a lion walking in mud versus a lion walking in gravel. It's the very same behavior, yet the traces are going to look different because the substrate is different. And identical traces may be produced by different species. So one trace you cannot necessarily link to one particular animal species. And lastly, two or more organisms may produce a single trace. Think of a burrow that was started by a shrimp. The shrimp died, and another animal like a fish now inhabits that burrow and expands it maybe a little bit. But that's very rare, I have to say. So today's main topic is going to be 320 million year old trace fossils from northern Alabama, and David Kopescu-Merkel is going to take over from here.
Thank you. These rocks are early Pennsylvanian in age, and could we look at the next slide, please? On the left in the green and the blue is part of the geologic time scale. This is the Carboniferous period, and the upper part in blue is the Pennsylvanian. And all of the Pennsylvanian rocks in Alabama are assigned to a single formation. It's called the Pottsville, and they're all early Pennsylvanian in age. We don't have any of the later part of the Pennsylvanian preserved. The picture on the upper right here is an artist's conception of a tropical forest of that might have lived in the Pennsylvanian period. A lot of the fossils that we have are from such forests, and they were widespread at that time. The picture on the lower right is a map of the globe from the Pennsylvanian. And this was a time when all of the world's continents came together into one continent, a supercontinent called Pangaea. And in this picture, it's been labeled so you can see the different parts of Pangaea, which modern continents they correspond to. So North America in the upper left, South America in the lower left, Eurasia, most of it in the upper right, and so on. Another thing about the Pennsylvanian is because there were so many of these vigorously growing forests, they actually raised the oxygen level in the atmosphere. In fact, the Pennsylvanian was the time when the oxygen level in the atmosphere was greater than any other time in Earth history. Because of that, insects were able to grow to a large size because their lungs, if you will, are kind of inefficient, which is one reason they're small. And so, with a lot more oxygen available, they were able to grow so that dragonflies, for instance, were up to a foot across. Let's see. Next slide, please. Okay. The map on the left is the map of Alabama showing all the county outlines. And one county, Walker County, is shown in red. And that's because Walker County was kind of the epicenter of the fossils preserved in the Pennsylvanian. It's sort of in the middle of the area, and there are lots and lots of fossils from that county. The map on the right is a reconstruction of what this part of the Earth probably looks like. We've got Mississippi and Alabama, parts of some of the states nearby, and the little yellow-green star with the white arrow pointing at it, that's Walker County, right in the middle of a big coastal plain area, like the coastal plain in South Alabama today, but with huge forests leading to the development of coal swamps. Now, as I mentioned before, this was a time when all of the continents were assembled together into one supercontinent. And so this part of Pangaea consisted of South America, which moved in from the southwest, and Africa, which came in from the southeast, and both of them slammed into North America, raising mountain ranges that they were very high at that time, like the Himalayas are today. And the Appalachian Mountains were probably about that tall. This was actually the third time that the Appalachians grew, because there were other episodes like this one that happened much earlier in the past. But as soon as the Appalachian Mountains started to grow, rivers and streams started to destroy them, and they eroded the mountains away and deposited sand, silt, and clay in coastal plains, including the one that had the coal swamps in it on the west side, which is the area that we're concerned with. And the Black Warrior Basin, that blue area in the middle, was an arm of the ocean at that time that was flooded. Next slide, please. This is a map of the northern half of the state, showing in light blue all of the Pennsylvanian rocks that are exposed at the surface right now. And you can see Walker County is right in the middle of the main part, but the northeastern half of Tuscaloosa County also has a lot of Pottsville exposures. And in fact, here in Tuscaloosa, if you drive down River Road and look away from the river, there's an area where there are lots of cliffs on the other side of the road, and those are Pottsville Formation. They're held up by sandstone. The Pottsville is mostly made out of sandstone and shale, but the shale is a softer rock. And in the lower Pottsville, that's pretty much all we have. But in the upper part of the formation, there are a whole series of cycles of sandstone, shale, coal, repeated one on top of the other. And those coal beds are the source of all of Alabama's coal deposits that have been mined. And they're also where the trace fossils and other fossils come from. This is an example of what the Pottsville looks like, with the sandstone layers sticking out and the recessed coal layers. This formation actually is exposed from Mississippi all the way to Canada, and it's named for Pottsville, Pennsylvania, because that's where the formation was first described. This is an outcrop. It's called the Stephen C. Minkin Paleozoic Footprint Site. It's one of the most important sites that we're going to talk about today because there are more trace fossils found here than rocks of this age anywhere else in the world. And so that makes it really valuable for study scientifically. In the background, you see a cliff that's called the high wall. And surface coal mining, they dig a hole and they start to dig across the land, digging down to wherever the coal is. And at some point, they decide to stop. The coal runs out, or it's not as thick, or whatever. And that's a cliff, which is called the high wall. And then all of the rock that they dug up from on top of the coal, they dump back down. And that's what we're seeing in the foreground. Those are mostly slabs of shale. Those people are looking for fossils in the shale. Normally, coal mines are reclaimed. That's a federal law. But we got a special dispensation for the government to preserve the Minkin site because it's so important scientifically. Next slide, please. This is another site near Carbon Hill, 23 miles farther west. And there are 3 coal beds that you can see in the high wall here. Next slide. This is a map of most of Walker County and also parts of adjacent counties showing the little dots are towns and the X's are coal mines where trace fossils and other fossils were found. So you can see there are actually quite a few sites where these were found. And they're mostly from the same part of the Pottsville, and they're very similar fossil faunas, kinds of trace fossils and plant fossils in the different places, but not exactly the same. And Andy Rinsberg will talk about the environments and how that might be different later on. So that's the end of what I'm going to talk about right now.
Well, now let's look a little bit further into these trace fossils Ron viewed. Let's go to the first slide. The history of track discoveries in Alabama is quite interesting. It goes back almost a century now. But fossil tracks in Alabama were first found in the 1920s in an underground coal mine near Carbon Hill. The name of the mine was the Galloway number 11 mine. And the tracks were particularly stunning because a whole trail of tracks were found along the ceiling of a mine tunnel in the Galloway number 11 mine. And here you see Walter B. Jones. He was the state geologist at the time. And there's a quote. The quote above him was that geologists were somewhat startled to behold the trail of the animal leading for some 40 feet along the roof of the slope until it disappeared into solid rock. That must have been a remarkable thing to see. So that was in the 1920s. Now, mining officials were aware that this could be a potentially important discovery. And in the next slide, they invited the associate curator of paleontology from the American Museum of Natural History, a fellow named George Gaylord Simpson, to come to Alabama and view the tracks and maybe collect specimens, take back to his museum. And in the memoirs of George Gaylord Simpson, who would become one of the foremost evolutionary biologists in the world later in his life, in his memoirs, he's quoted as saying, "A day spent weirdly and unsupported by the solace of tobacco in the depths of a coal mine, looking for the footprints of animals dead since 250 million BC. And that number is based on an old calibration of the rock record. Now we believe these fossils to be more like 320 million years old, not 250 million years old. But in any case, the discovery attracted the attention of one of the biggest museums in the country. Now, 70 years went by before anybody did anything about these tracks beyond what was already done in 1930. And that happened in the next slide when Oneonta High School science teacher Ashley Allen visited a mine called the Union Chapel Mine, which is near Jasper, Alabama, and which David said is 23 miles east of Carbon Hill. Ashley, and the name of this mine was the Union Chapel Mine. Ashley found fossil footprints at this mine. Now, Ashley was a member at the time of a group known as the Birmingham Paleontological Society. This was a group of local amateur collectors. And of course, this group was extremely interested in knowing more about these fossils and collecting them. And one of those members is on the next slide. His name was Stephen C. Minkin. Steve Minkin was a licensed professional geologist, and he recognized early on that these were not the kinds of fossils that one just takes home and puts on a shelf. He believed that the fossils, the trace fossils of Alabama, were scientifically important, significant, and that they needed to be photographically documented. And not only this, he believed that the site needed to be preserved for future study, that it had to be protected from being reclaimed, which was inevitable at the time. Now, he wanted people to bring their fossils in to be seen by professional paleontologists, and so he organized these events that became known as track meets. And in a track meet, a fossil collector would bring their track specimens to a common area, lay them out on tables, and prepare them for photography by someone standing at the photography table elsewhere in the room. And then at the same time, a professional ichnologist would get to see them. And these track meets were very effective, and he also encouraged people to donate their specimens to the local museums in Alabama. So that was the role of Steve Minkin. And in the next slide, Steve Minkin's vision of preserving the site, it turned out, had to go through, it seemed to require an act of Congress. And in this picture, Dr. Rinsberg, who's here speaking with us today, is speaking with Representative Robert Adderholt, Alabama representative at the Union Chapel Mine in 2004. And I want to note that the group, the amateur collector group, changed their name to the Alabama Paleontological Society in 2002. So now the group is known as the APS. In any case, Representative Adderholt was there to see the site. There are specimens laid out, and to try and appreciate the value of protecting the site from reclamation, which was inevitable since that's what a coal mine is supposed to do. That's what they're supposed to do with a coal mine once the mining is over. Now, it turns out that the site preservation effort was successful, as shown in the next slide. The state decided that the Alabama Department of Conservation and Natural Resources could take over the site. At the time, Jim Griggs, shown in the picture at left, was the director, and the member of the APS who spearheaded much of the work on this was Prescott Atkinson, shown to his left. Now, Steve Minkin passed away in 2004 after an accident at his home, and the group decided to name the site after Steve Minkin. So this became known, the Union Chapel Mine became known as the Minkin Paleozoic Footprint Site. And so that's the story behind that site. Now let's go to the next slide. The age of these fossils is extremely interesting, and it is based on, in Alabama, the age is based on what we know, what we call index fossils. And index fossils are fossils that had a very short period of existence, such that if you find these fossils in layers of rock that already have a known age, then you can use those fossils to get the age of other rocks that haven't been dated yet, but which have those fossils. And when you do that, you discover that these tracks are 320 million years old. And there's an interesting aspect to this. In Jennifer Clack's book, Gaining Ground, The Origin and Evolution of Tetrapods, she says it is during the Westphalian that the first remains of animals that can confidently be called reptiles are found. And that matches perfectly with the time frame of the Minkin Paleozoic Footprint Site, indeed of all the Walker County rocks, which means we can confidently assert that the animals that lived in this area were some of the earliest reptiles that ever lived. Now we can look at this age again in another way by transforming the geological column in Alabama to a picture of the orbit of the sun, where you can label the different epochs of Earth history as different points along the orbit. And one thing you realize is that these fossils are more than one orbit of the sun around the galactic center. And if you look at this diagram, you see that the age of dinosaurs begins approximately 1 galactic year ago, about 243 million years ago. That means the Minkin site and the other fossil sites in Alabama with tracks predate the first dinosaurs by 82 million years. Let's go to the next slide. Now, when you find trace fossils, you find they come in pairs, an impression and a counter impression. And the impression is just the footprint left in the mud where the toes would leave depressions in the mud. The counter impressions are made of the mud that filled the impression, and therefore they're elevations in the fossil. We call the impression the negative of having negative epirelief, and we say the counter impression has positive hyporelief. But you usually find them in pairs. The next slide. And trackways also come in two basic types. Surface tracks are tracks that are made at the surface. And when you find a surface track, it means that the animal's feet were in contact with that surface. But there are also tracks known as undertracks, and undertracks are distortions of the layers below the animal's feet due to the animal's weight. Surface tracks have a low preservation probability because for example, if they're made on a tidal mudflat, they can be washed away the next time the tide comes in, or they can be severely smoothed out in the next tide. But undertracks are already buried, and they have a much higher preservation probability than surface tracks. And as a result, most of the tracks found in Walker County and most of the tracks you'll see in our pictures are undertracks, not surface tracks. The next slide. This shows how you can lose information in surface tracks. You can have a surface track with 5 digits and its counter impression shown above here. But as you go to the next layer below the surface layer, you notice that some information is being lost. Not all the digits are being transmitted to the lower layers. And when you get to deeper undertracks, you might only see 3 digits in a footprint when there should be 5. And so that should tell us, that tells us that you have to be very careful when you interpret fossil tracks, when you interpret trace fossils, because undertracks can show what we call undertrack deficiency, the loss of information the deeper the undertrack. The next slide. Now, these are just a few special trackways. This is a trackway showing obstacle avoidance. A small amphibian is walking around an obstacle. And the picture at the bottom of the frame, you see a phantom amphibian put in the trackway. In the next slide, the image has been enhanced to show possible evidence of early group behavior, where you see a lot of footprints from similar sized animals going in the same direction. And the next slide. Most of the tracks in Alabama were discovered within a meter of the top of the Jagger coal seam, which is shown by the arrow in this picture. And this picture shows a coal excavated cavity from the 1920s, and tracks were found in the rubble inside that cavity. So the tracks come from a well-defined part of the layers of rock above that coal seam. And you see at the bottom a trackway found from that cavity, which is a meter long with 35 footprints. In the next slide is a beautiful trackway called a Tenosaurus subulensis, made by an animal that was probably the largest predator on the early mudflats. And on the next slide, you see an animal walking into wet mud or walking into water because the footprints get better as it goes on. And the next one. And that's all. I now yield to Dr. Rinsberg.
Thank you, Ron. Let's have the next slide. Hmm? And the next.
Hey, hold on.
What?
He said that you were supposed to be next, but
Oh.
actually, this is my section. That's why those didn't look familiar.
My bad.
My
Yeah.
apologies.
Back
That's
to mute.
So I want to start off by talking about the differences between amphibians and reptiles, which are kind of amniote, because both of these were very common at the Minkin site and at a lot of other trace fossil sites in the area. So the picture on the left is the trackway of an amphibian. The trackway is called Nanopus reedii, and on the right is a picture of an amniote, a reptile called a reptilian trackway called a Sycosaurus cabi. And you'll notice a couple of differences. First of all, if you look on the left, you see that the manus prints, the forefoot prints, are much smaller than the pes prints, the hind foot prints. This is typical of amphibians, that the forefeet were a lot smaller than the back feet. Secondly, the toes on the amphibian, the tips of the toes are rounded. They have kind of stubby, rounded toes because they didn't have claws. And the last thing is that the forefoot, the manus print, only has 4 toes. Most amphibians only have 4 toes on their 4 feet. The picture on the right, you can see all of these things are different. The manus prints have 5 toes. The toe prints are very sharp because the reptiles had claws, and the forefoot print is only a little smaller than the hind foot. Next slide, please. So these are paintings of artistic impressions of 5 different animals that are thought to be responsible for 5 different sets of tetrapod footprints from these sites. They were made by Sue Blackshear, a local artist. So on the top are 2 different amniotes, which were pretty small, and in the middle, 2 different amphibians, which were of similar size, and at the bottom, anthracosaurs, which were reptile-like amphibians, and they were much larger, as Ron mentioned. These were probably the top predators at the time, because most amphibians and most reptiles are predators, and your size determines who else you can eat, and they were the largest. Next slide, please. So these show 2 amphibian trackways. The one on the left is Matthewichnis caudifer, which is characterized by having a very long middle toe on its pes print. I don't know how well you can see that, but that is pretty distinctive. And this is also a very shallow undertrack. And we know that because you can see the tail drag mark going down the middle of the trackway, indicating that it was made close to the surface, because tail drag marks are not very deeply impressed. The one on the right is Nanopus reedii, which is the most common trackway at the Minkin site. And you can see that this one, the toes on the pes are all more or less the same length. The middle one is pretty short. Next slide, please. This is another picture of Nanopus reedii with the arrow pointing to one of the manus prints, which is so much smaller than the pes prints. And here again, you can see this is a shallow undertrack because there's a partial tail drag impression going down the middle of the trackway. Next slide, please. The anthracosaurs made the trackways called that Ron mentioned before. And this is a pretty large one. Notice it's a fairly deep undertrack because you can only see 3 of the toe prints from the middle 3 toes on the back foot, and with an adult person's hand to show you the size of it. This is 2 more examples of the same track. Notice the one on the left, you can actually see all 5 toes The two on the outside leave very short prints, and it's pretty rare to see all 5 of them because virtually all of these are under tracks. And the one on the right is kind of confused looking. I think it's 2 footprints, one on top of the other. And the scale there is in centimeters, which gives you an idea of how big they are. Next picture. And this is another picture of a Tenosaurus subulensis. The large track on the upper right is one of those. And on the left, there's a much smaller amphibian trackway, an example of Nanopus reedii with the well-developed tail drag mark going down the middle. Next slide. This is a picture of Syncosaurus cabi, which is one of the reptile trackways. In fact, this is the most common reptilian trackway by far at the Minkin site and at probably every other site in the Walker County area. And this is the holotype, which means this is a photograph of the specimen that Truman Aldrich used to describe the species when he named it back in 1930. If you're naming a species, whether it be a fossil trackway or any other kind of species, you have to pick one specimen as your example that you think shows the characteristics of the species best. And this is the one that Dr. Aldrich chose. Next slide, please. This is another example. Well, it's the same photograph at the bottom, but the bigger one on top is another example of Syncosaurus cabi, showing the well-developed Manus and Pez tracks. And you can see that here, not all of the footprints are visible on the Pez because it's a deeper under track. Next slide, please. And this is an even deeper under track with only 2 or maybe 3 of the footprints visible on the Pez. This is the other reptile that left trackway that was found at the Minkin site. It's called Nodulacerta. Read it very well. And it was much smaller than Syncosaurus cabi, and the 3 little white arrows point to the middle toes on the Pez print, showing that this one also had an extra long middle digit. It's kind of interesting that one of the amphibian species and one of the reptile species had extra long toes. Next slide, please. And now we're back to Andy.
Thank you, David. Sorry, I didn't mean to steal your thunder. Well, let's go forward. Thank you. Before I get started on the invertebrate trace fossils, I'd like to do a shout out to all the people who made this possible. Going back to 1929, and Dr. Jones, who got his paleontologist on the staff of the Geological Survey of Alabama, Truman Aldrich, to work on these. Aldrich was a malacologist. He wanted to study fossil seashells, but he worked it up. They published, and as far as I know, very few people ever read this publication. So Dr. Simpson did have a collection of these, and the story of the rediscovery of these fossils at the American Museum of Natural History is quite an interesting one. And on June 1st, Monday, 7 p.m., the Alabama Paleontological Society will be having Dr. Carl Mailing of that museum speaking about those Simpson fossils. So if you're interested in that, look up the Alabama Paleontological Society online, and we'll have an online meeting. So zoom forward 70 years, nobody's worked on them. Sorry. And a teacher, a science teacher named Ashley Allen up at Oneonta High School, asks his students, does anybody know where we can collect fossils? And one of them pipes up and says, my grandmother has a coal mine. So he went and visited, one Saturday and found amphibian tracks and got really interested. He called up his old teacher at the University of West Alabama, Richard Thurn, the late Richard Thurn. Richard Thurn is a mineralogist and petrologist. He studies rocks and minerals. He didn't know about that much about trace fossils, but he knew who to call. That was me. And David Kapaska Merkel and I got permission from the state geologist to go up to Walker County and scout it out. We got really excited. Ashley got really excited. Ashley got the members of the future Alabama Paleontological Society very excited about that, to the point where they started a rescue operation of this coal mine that was going to be closed and covered over and lost to science. So they went out every month on one Saturday, and they've been doing that for the last 20 years. So we have thousands of specimens from this site. About 90% of them are in private hands. The 10% that are of the greatest scientific interest, however, have been preserved in the Alabama Museum of Natural History, the Anniston Museum of Natural History, and most especially the McWane Science Center in Birmingham. So, and a lot of these have also gone out of state to other museums because of the sheer volume of material. Dr. Buda mentioned track meets. This is one of the early track meets. That's yours truly in the lower right corner, peering at a specimen, and a group photo to the left. Eventually, we brought in people from all over the country and from Germany to examine these specimens. We had a scientific meeting that the local Paleontological Society helped greatly with in 2003. In 2005, we published our book, which is still in print, but it's also available online. And the references for that are at the end of this talk. So let's move on to the next slide, please. So let's take a look at the rocks that these trace fossils are in, the layering. We call these the Syncosaurus beds because Syncosaurus is present in them as an important trace fossil. And it was about the 1 meter or 3 feet above a coal bed, which is no longer exposed. And you can see immediately that there's a rhythmic quality to the bedding, that there seems to be a thick sedimentation, then thin, thick, then thin, thin, and so on. Now, Dr. Jack Passion of the Geological Survey looked into these, and he reasoned that these were created by different events. One event where the water slowed down and dropped its mud, which later becomes shale. Then another event where the water picks up speed, but it's still dropping mud, so you have a thin layer. And that happens frequently in tidal flats, where the water comes in on the flood tide, and then it slows down, drops a lot of sediment, and then ebbs back toward the sea. So we knew very early that this was an intertidal environment. And what was more, Dr. Passion was able to count these layers like the rings in a tree and found that they repeated in a rhythm of about 30 of these pairs. In other words, he was following a lunar cycle. These are lunar tides. Next slide, please. Okay, we were thinking tidal flat. Of course, when we saw these dimples in the upper part of the slide, we thought, oh, well, rain fell. These are raindrop imprints. And that's what we thought for a while. But, you know, you don't usually get raindrop imprints unless you also find mud cracks. And we didn't find mud cracks. We had no clear evidence of this tidal flat being exposed to the air long enough to really dry out. So I looked into these more, and I found, no, these are the structures left by gas bubbles as they're rising through the mud before it's solidified. And this turns out to be very common in tidal flats too, so it's no big worry. Methane or natural gas is very commonly generated in this mud. Next slide. Oh, and by the way, yes, when we looked at these trace fossils, we were beginning to deduce who made them. We had trace fossils that we could trace back to amphibians, to reptiles, to fishes, clams, horseshoe crabs, which are usually found in the sea, millipedes, which are never found in the sea, and insects, including larval insects. And they really do not like salt water. So we had something that was at the edge of the sea, a place where horseshoe crabs felt comfortable coming in. And we know that they generally do this when they are mating and having their eggs. So this is where baby horseshoe crabs are born or hatched in estuaries or bays, which usually have lower salinity than the open sea, usually because some river is coming in, and that would also account for the amount of mud coming in, because rivers can be very muddy. So when we're looking at this assemblage of trace makers overall, we decided this had to be fresh water. Amphibians and insects in particular really do not mix with salt water. So think saltwater frogs, they're extremely rare. So we were thinking this really had to be a fairly strong river with a good deal of fresh water coming in, enough to dilute the seawater of the bay. So we're at the head of a bay, and modern analog for this would be Mobile Bay in Alabama, where you have a very muddy river coming in. It has an extensive delta, and at that end of the bay is nearly fresh. So here in Alabama today, we have an analog that can teach us about this ancient assemblage of traces. Next, please. Okay, other evidence. Again, the little ruler, the scale on the side is 5 centimeters or about 2 inches long. So here we have a fossil fern. It turns out that plant fossils are quite common in our rocks, but they're not in place. They're just bits and pieces of them. We do have coal mines in Alabama where we find the roots. The other kinds of fossils are not common at all. They're quite rare. Next. But occasionally, we do find some very interesting ones. There are insect wings. This dragonfly, early dragonfly wings, most of which have been found by a single collector, Prescott Atkinson. Next. We find no shells of bivalves or clams, but we do find evidence of clams moving around. Although this looks like a dead worm at first sight, it really probably is, based on other specimens that have been found elsewhere. The trace of a short-bodied animal that was just inching along. Part of the evidence for that is the sharp change in direction. Long-bodied animals have a hard time, changing direction fast, but short-bodied animals can turn on a dime, or a penny in this case. Next. Some of the most interesting trace fossils here are horseshoe crab trackways. Now, Dr. Clockmaker showed you one with the horseshoe crab at the end of its last trackway. We don't get that lucky here, but you can see from the inset picture of a modern horseshoe crab that they have several legs, and so they're going to have quite a few imprints. Next, we'll see close-ups, and we can even see, if you look at the yellow circles, that they ended in 2 fingers or digits, which we also find in some modern horseshoe crabs. So we're pretty sure that we got the identification right. Next. We can even see that they were probably acting in a social manner. You can see two long trackways here on this slide, and they seem to be paralleling each other. And we see this quite a bit. Apparently, they were there at the same time. And remember, these mud layers were laid down within a few hours and then buried forever. Well, for the next 320 million years, anyway. So what we have here is some of the earliest evidence of social behavior in horseshoe crabs. We also have, and I'm sorry I don't have a slide of this, but we have cases where fishes seem to have been paralleling each other as well. They make wavy trails, and this is the oldest known evidence of schooling in fish. Next, please. And we also have insect trackways. So we don't just have the wings as evidence that they were there. Can you see the triplets, the groups of 3 imprints? That's how we know how many legs the maker of this trackway had. This is one of the best evidences that this was fresh water, because you know a dragonfly wing can float out to sea, but this insect actually walked on that mud flat right there. Next, please. Less obvious as insect-made trace fossils are Treptichnus, which is a zigzag burrow, and these U-shaped burrows. Now, I call them U-shaped, even though they look like straight line segments, because you have to remember the mud was laid down pretty soft, and it got compacted by the weight of sediment that was deposited on top of it. So we think that they've been somewhat flattened out, and that they're originally shallow U-shapes. Next, please. And there's another zigzag burrow. Now, we have found a modern analog, or Dr. Alfred Uchman of Poland has found a modern analog in the larvae of modern flies. So we have a good handle on the maker of this one as well, even though it looks nothing like an insect. Next, please. And then we have mysteries. There have been a couple or 3 trace fossils specimens that look like this. We don't really know enough about them yet to slap a name on them, but still working on some of these things. And although people have been going to this mine for 20 years, every month, it still produces, this one site continues to produce new information. Things that we've never seen before keep turning up. Next, please. Okay, to sum up, we have an environment that was a freshwater intertidal mudflat, and we have some of the associated bay or estuarine facies that are somewhat saltier, probably. The preservation is really good, excellent, because the sedimentation was very rapid, and we have a lot of traces. If you went to this site, along with the Alabama Paleontological Society on their monthly trips, which they do allow by reservation, you are very certain to find something. However, you probably will not find very many different kinds of trace fossils. So this is like many estuaries. It's a great place to live, but you have to be well adapted to the changing conditions as the tides come in and out, as the salinity changes, as storms come in. It's a difficult environment to live in. And this is very typical of Mobile Bay today. We do, because of the abundance of specimens, see young stages of trace fossils. In other words, we see specimens that are small, made by young animals, and we see specimens of the same kind that are made by older, larger animals. So we have Treptichnus in different sizes. We have the horseshoe crab trackways in different sizes as well. Likewise, the amphibians. So we have an opportunity here to study the life stages of the trace makers, even though their bones and shells are not preserved today. And finally, this is a great example of a successful cooperation between amateurs and professionals in science. And in fact, our amateurs have become so expert at this that it's really not quite right to call them amateurs anymore. I call them citizen scientists now. The line has been blurred. Next slide. Dr. Jim Lacefield, one of the Alabama Paleontological Society members, has produced his own book on the geology of Alabama. And this is one illustration from it showing his reconstruction of what this mud flat might have looked like, with the amphibian making its tracks by the shore there. And remember, there would have been a delta nearby with swamp vegetation of an antique kind nearby, and we do get to see abundant evidence of the plants as well. It's all in here. Thank you. Dr. Klompmaker, back to you.
Yeah, thank you for the excellent presentation here. I wonder if there are any questions that came in during the episode. Ellie, do you know?
Let's see. We did have some people who really enjoyed the discussion, and I personally agree with Sandy. I think all of this is really fascinating, and we did get a comment about Lacefield's book, saying that it was great. I just have a quick question for you guys. What would you recommend to like young aspiring paleontologists who are interested in this kind of subject? What would you recommend that they do or read in terms of wanting to explore more about trace fossils? That's an anybody question if you want to hop in.
I would say try and learn all you can. At the library, find books on the subject and read as much about it as you can. And if one is old enough to join a fossil collecting group, they should do that as well.
Yeah, it seems like a lot of the experience of going out there is kind of what helps you learn about everything, is actually going out and doing it. It's a very hands-on study, I guess.
And actually, the Alabama Paleontological Society allows young people to go with them on their trips to the Minkinson site as long as they have an adult with them.
That's really cool.
And I will say too that the resources that we mentioned today are really great ways to kind of get to learn. Like Dr. Buda said, make sure that you check out your local library. They've got amazing resources. Discovering Alabama also has some incredible resources about the site that we have talked about today, the sites we talked about today. Oh, look at that. Pam and I, we're right in the same boat right now. But these, yeah. Oh, yeah. Go ahead, Dr. Rinsberg.
This has produced a video on this site that we should also give a shout out to.
Oh, can you say that one more time? I think I accidentally muted you. Who produced the video?
Discovering Alabama has a TV show, half-hour long, and I believe the teachers and students' notes are available online.
Yes, there should be a teacher guide for that as well. So you can go to discoveringalabama.org for that information. We don't have a lot of questions, but it seems like a lot of folks really enjoyed y'all's talk and the discussion about everything. So Ashley said, great job. And then we got a great talk over here. So I guess we can wrap it up if there are any other questions. Allie, do you have any questions before we go?
I think that I don't know. I've learned so much from that talk. I don't know that I have any questions for her. I'm still processing all the information I learned. I loved that. That was great. And I love too that like, estuaries today are kind of like the nurseries of the world, everything, a lot of life happens in estuaries, and it seems like it was no different back 320 million years ago, which is kind of a wonderful thing.
Yeah, I think I'm gonna have to rewatch this to get more information out of it, because there's just so much. But it was really good, and I'm looking forward to learning more about this subject. So I guess we will go ahead and wrap it up. If there are no more questions, I'm gonna do one last check. We did get a good job, everyone, from Mary Beth about the different types and formations. So I guess we'll go ahead and wrap it up, since it doesn't look like there are any questions. So that's going to do it for this Museums from Your Home live stream. We'll be doing this every weekday, Monday through Friday at 10 a.m. And each day will feature a different aspect of UA museums. Tomorrow, we're going to be coming back to the Alabama Museum of Natural History's Facebook page, and we're going to have a Family Friday. Fridays are more centered on kids and families. So if you are interested in that, come back and join us for that. And if you have any questions about our live streaming schedule and anything we're doing here with the Museums from Your Home initiative that we've got going on with UA Museums, you can go to museums.ua.edu/museums from your home. That's going to be kind of your one-stop shop for our live stream schedule and our archived live streams. If you missed any of these, if you came in late to the trace fossils one, you can just go back to museums.ua.edu/museums from your home, and it will be there, and you'll be able to find it. We also have some educational resources from Discovering Alabama, from the Alabama Museum of Natural History, as well as Moundville Archaeological Park. And we also have a coloring book. I should mention that. We have a UA Museums Color Collections coloring book that will be available there for you on that website. If you want to keep in touch with all of our video content and our live streams, if you want to have a really easy way to follow along with that, you can go and subscribe on YouTube at youtube.com/UA Museums, and that will make sure that you never miss a live stream. It will notify you when it happens, and you will also be able to follow any of our video content that we've been creating, our isolation observations, our Moundville Monday series. So that is a good way to keep in touch with us there. And if you are liking anything that we are doing here and you want to support UA Museums, you can go to give.ua.edu/museums. That will give you the opportunity to become a supporting member, and you can support UA Museums that way. And I guess that's going to do it for us. And if you haven't gotten a chance to watch this, you can watch it later. So tell your friends if they are interested in this. And I guess thank you to everybody who was joining us live and enjoyed the talk, and anybody who will watch this in the future. Thank you for visiting UA Museums from Your Home. All right, well, hope everybody has a great day, and thank you for everybody who came and chatted with us today on the stream.